Hello everybody. We are going now to solve this Kirchhoff's circuit, and I know we need to use the Kirchhoff's rule because we have two batteries in one loop, and that makes it a little bit hard just to apply Ohm's law to solve this problem. So in this problem we have a 12-volt battery, and this battery is going to push the current this way, and we have a 10-volt battery, and this battery is going to push its own current this way in the opposite direction. However, if you look at it, because this is called an electromotive force, so if you think about it as a force, it is not, but if you think about it this way, there's a 12-volt battery pushing this way and a 10-volt battery pushing this way. Which one is going to win? I would believe that the 12-volt battery would win, so I am going to assume that the direction of the current in this circuit going to be this way, and I'm going to call this current I. Since we have one loop, we will only be concerned with one current, I. Okay. Now in other loops, sometimes when they are mixed with another loop or something like this, or a loop into a loop, you will not be able to find out exactly or to determine exactly where the current direction is. So you just put a direction, and if you get the answer for the current to be negative, then your assumption of the direction at the beginning was wrong. You just reverse the direction, but the value is still good. All right, so we need to find the value of this current. Since we don't have junctions, so we're not going to use the junction rule, we're going to just use the loop rule. And the loop rule says that the summation over all the voltage drops in a circuit that is closed must equal to 0. And the way we do that, we're just going to start at a point, a certain point. I'm going to just choose this one, and I assume the current is going this way, so the current will always be going this way. All right, so no change about that at all. And this current is valued as I. Remember that Ohm's law says V equals IR, so any voltage drop across a resistor must equal to the I times R. All right, so now since the current is going this way, so this must be positive, negative. Now this is negative and this is positive because that's what the battery is telling us. And this is positive, negative, and this is positive, negative. That's what the battery is telling us too. But since the current is going this direction, so it goes from the higher potential, lower potential, higher potential to lower potential. All right. Now I chose this point to be the direction where I start, and I'm going to choose what? This kind of like travel direction. All right, so I'm going this way. There's a voltage drop here because I'm going from the positive to the negative, so I'm applying this equation, and this voltage drop is going to be, since it's a drop, it's a minus, and the current is I times R, and R here is 3. Okay, so you can just plug in the value of R quickly. Now keep going, keep going, keep going. I'm traveling, remember, keep going on this wire, and you have minus to positive, so you are gaining from minus to positive, so that's plus 12 volt. Keep going, 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 going like this way. All right, you're going from positive to negative, that's a drop, so you have to say minus. Minus how much? I times R, and R's value is 1. Keep going, that's positive to negative, that's another drop, so minus the value of this, so minus 10. Keep going, keep going. All right, you hit the same point you started at, and then you can just say that's equal to 0. All right, now this is just an algebraic equation with one unknown. We can solve it because that's equal to minus 3i plus 12 minus 1i, 1 times I is I, minus 10 is equal to 0. Then minus 3i minus 1i, I'm just adding these two. Plus 12 minus 10 is plus 2, and that should be equal to 0. Then minus 4i is equal to minus 2. I took to the 2, the other side becomes minus. Then I should be equal to 0.5 amps. Since it's positive, then my assumption of the direction is correct. And that is it for this one. Now we might be able to look at more problems with more than one loop. All right, thank you.